My namaskar and a very good afternoon. I am Khushbu Agarwal, working as Assistant Professor in Botany at Kalahandi University. First of all, esteemed, sorry, sir. Thank you. Honorable Vice Chancellor, Kalahandi University, Professor Sanjay Kumar Satpathy sir, esteemed PG Council Chairman, Dr. Major Jaidev Sahu sir, all the dignitaries present on the dais, and our today's speaker who have joined us online and on screen, Professor Bedangadas Mohanty, Professor in Physics and Dean at NISER Bhubaneswar, all the dignitaries who have joined us offline, and my dear students. I welcome you all to the weekly motivational talk series that is known as Uttisthata by Kalahandi University to its 18th episode. So I request all of you to give a huge round of applause for celebrating 18th episode of this motivational talk series. So once again, I extend my warm welcome to all of you, and without much delay, now let's start the today's program. So first of all, may I now request our singer, Miss Lipsa Maharana, to give the warm welcome song. Lipsa, please.
Thank you so much, ma'am. ସମସ୍ତଙ୍କୁ ମୋର ପ୍ରଣାମ, ଶୁଭ ସନ୍ଧ୍ୟା। ଆଶିଷ ଦିଅ ମା, ଆଶିଷ ଦିଅ ମା, ନ ଡରି ଅନ୍ଧାର ଝଡ଼ ଝଞ୍ଜାଗର ଅନ୍ଧ ଦୁନିଆର ସ୍ୱାର୍ଥ ଲଲକାର ଚାଲିଛି ଆଗେ অভিলাষা মোর তব অর্চনা মা, আশিষ দিও মা, আশিষ দিও মা, আশিষ দিও মা। ন জানি পূজার আচার বিভার ধূপ দীপ নৈবেদ্যর সম্ভার অন্তরে মোহর তরূপ সুন্দর অঙ্কিত হিউ মা, আশিষ দিও মা, আশিষ দিও মা, আশিষ দিও মা। ধন্যবাদ ସମସ୍ତଙ୍କୁ ଅତ୍ର ପ୍ରଣାମ।
Lipsa, for such a warm start. Now, I will say that we are indeed much lucky to have such a distinguished and a very rare personality among with us today as our guest speaker for today's episode of Uttisthata. So let's know more about him from our PG student Shraddha Suman Panigrahi, PG second year physics. So may I now request Shraddha Suman to introduce our today's speaker nicely. So Shraddha, please.
Thank you, ma'am. Good afternoon, everyone. Once again, welcome to the 80th talk of Buddhism, a motivational talk series. Our today's speaker is a remarkable persona in the field of experimental high energy physics. A scientist of eminence, a prestigious member of the scientific society, Dr. Mohanty prefers extraordinary contributions to the world of particle physics. After acquiring his bachelor's degree in physics from Ravenshaw University, Cuttack, and completing his master's in physics from Utkal University, Bhubaneswar, he went forward to complete his PhD in the Institute of Physics, Bhubaneswar, in the year 2002, for which he was also awarded with the best PhD thesis in nuclear physics. Sir had been a DA KS Krishnan member and scientific officer at Variable Energy Cyclotron Center, VECC, Kolkata, till the year 2012. Meanwhile, as a postdoctoral researcher at Lawrence Berkeley National Laboratory, California, he had a dynamic role in the performance of the infamous STAR experiment at the Relativistic Heavy Ion Collider Facility, LHIC, Brookhaven National Laboratory, in the late 2000s. This includes being the spectra physics working group co-convener to being selected as the physics analysis coordinator and ahead becoming the deputy spokesperson from year 2011 to 2014 and then the council member of the STAR experiment. He was the co-founder of the Beam Energy Scan program at RHIC to study the quantum chromodynamic space diagram. Since 2014, Sir has been the editorial board member of ALICE at Large Hadron Collider CERN. Currently an associate professor and dean at NISER Bhubaneswar, he also served as the chairperson of School of Physical Sciences from the year 2013 to 2018. Professor Mohanty possesses an astounding award-winning career, amongst which the Infosys Prize in Physical Sciences 2021, J.C. Bose National Fellowship 2017, Swarna Jayanti Fellowship 2010 to 11 by the Government of India, INSA Young Scientist Medal 2003, and the Shanti Swarup Bhatnagar Prize for Science and Technology in the year 2015, which, as we all know, is the highest science prize in our country. Elected as a member of Indian National Science Academy, New Delhi, Indian Academy of Sciences, Bangalore, National Academy of Sciences, India, Dr. Vedang was also elected as a Fellow of American Physical Society in the year 2020. He has contributed to the establishment of quark hadron transition, pioneered the direct comparison between experimental high-energy heavy ion collisions data calculations, which the physics world considered it among the 10 best in 2011. At the young age of 30, his contribution to photon production and to the physics of DCC in heavy ion collisions led to the invitation from the editorial board of physics reports to write review articles. The greatest of all, he has made significant contribution to the discovery of quark-gluon plasma in the laboratory itself, which is believed to be the state of matter which existed in the first few microseconds old universe. Sir sure is an inspiration to physics enthusiasts. Now, without any further ado, with a huge round of applause, let's welcome the magnetic demeanor of the day, Dr. Bedangadas Mohanty.
Thank you so much, Shraddha, for such a nice introduction. I would say that words would fall short to elaborate such a dignified, such a personified personality on today's occasion. We have also with us in online our esteemed registrar, Shri Pitambar Boisar. I welcome you, sir, to the program of Uttishthana today, and I request you, sir, to give a warm welcome to our today's speaker, Bedangadas Mohanty, sir. Sir, please.
Namaskar, Honorable Vice Chancellor Kalahandi, Professor Sanjay Kumar Satpathy sir, respected Chief Speaker of this day, Professor Bedangadas Mohanty sir, respected Nakul Maji sir, respected Madam Khushbu Agrawal, respected CPGC Major Jagdish Sahu sir, respected all members of Kalahandi University family, respected all participants, dear students of Kalahandi University and Miss Lipsa Maharana. On behalf of Kalahandi University family, I extend my sincere welcome you all to this 80th motivational talk series. Today, we have chief speaker, Professor Bedangadas Mohanty sir. He will share his views on this topic on new inventions in science. So I again extend my sincere welcome you, sir. Today topic is new invention in science. So let me tell in Odia. ଆମେ ସମସ୍ତେ ଜାଣିଛୁ ଯେ ଭଗବାନ ହେଉଛନ୍ତି ସୃଷ୍ଟିକର୍ତ୍ତା, এই ବିଶ୍ୱର ସୃଷ୍ଟିକର୍ତ୍ତା ହେଉଛନ୍ତି ଭଗବାନ। ତେଣୁ ଭଗବାନ ହେଉଛନ୍ତି ସର୍ବଶକ୍ତିମାନ ବା ସୁପ୍ରିମ ପାୱାର କହୁଛୁ। ଏହି ସୁପ୍ରିମ ପାୱାର ମାନବ ବ୍ରେନରେ ଲୁକାୟିତ ଅବସ୍ଥାରେ ଅଛି, ଯୋଉଟା କି ମହାଗୁପ୍ତ ଭାବରେ ରହିଛି। ଯେଉଁ ମାନବ ବା ଯେଉଁ ବ୍ୟକ୍ତି ବା ଯେଉଁ ଛାତ୍ର ଛାତ୍ରୀ ବ୍ରେନ କୁ ରିସର୍ଚ୍ଚ କରି ସେଇ ପାୱାରର ଅଧିକାରୀ ହୋଇପାରୁଛନ୍ତି, ସେଇ ପାୱାର ବଳରେ ସେମାନେ ନୂତନ ଭାବରେ ସୃଷ୍ଟି କରିଥାନ୍ତି। ଯଥା ଆକାଶରେ ରକେଟ ଛାଡି ପାରୁଛନ୍ତି, ଏରୋପ୍ଲେନ ଚଲେଇ ପାରୁଛନ୍ତି, କିମ୍ବା ଅଥଲ ସାଗରରେ ଜାହାଜ ଚଲେଇ ପାରୁଛନ୍ତି। ତେଣୁ ବିଜ୍ଞାନ ମତରେ ବର୍ତ୍ତମାନ ଯୁଗରେ ବିଜ୍ଞାନ ମତରେ ସାଇଣ୍ଟିଷ୍ଟ ମାନଙ୍କୁ କହିବା ଆମେ ଭଗବାନ। କାହିଁକି? ତାଙ୍କ ସାଇଣ୍ଟିଷ୍ଟ ମାନଙ୍କର ବ୍ରେନରେ ଯୋଉ ସୁପ୍ରିମ ପାୱାର, ଯୋଉ ଭଗବାନଙ୍କର ସୁପ୍ରିମ ପାୱାର କହୁଛୁ, ସେଟା ଲୁକାଇ ଥିଲା। ସେଟାକୁ ସେମାନେ ୟୁଟିଲାଇଜ କରିକି ତାଙ୍କୁ ରିସର୍ଚ୍ଚ କରି ସେଇ ପ୍ରୟୋଗ କରି ସେମାନେ ନୂଆ ନୂଆ ତଥ୍ୟ, ନୂଆ ନୂଆ ଉଦ୍ଭାବନ ସୃଷ୍ଟି କରିବାରେ ସକ୍ଷମ ହେଉଛନ୍ତି। ତେଣୁ ଆଜିର ଏଇ ଦିନରେ ମୁଁ ଛାତ୍ରଛାତ୍ରୀ ଯୋଉ ଫିଜିକ୍ସ ଡିପାର୍ଟମେଣ୍ଟର ସମସ୍ତ ଛାତ୍ରଛାତ୍ରୀ ମାନଙ୍କୁ ଅନୁରୋଧ କରିବି, ଅଧିକରୁ ଅଧିକ ରିସର୍ଚ୍ଚ କରନ୍ତୁ, ଅଧିକରୁ ଅଧିକ ରିସର୍ଚ୍ଚରେ ଭାଗ ନିଅନ୍ତୁ। ଆଉ ଯୋଉ ବ୍ରେନଟା ଅଛି ଲୁକାୟିତ ଅଛି ସେଇଟାକୁ ମାନେ ପ୍ରୟୋଗ କରନ୍ତୁ, ଯାହାଦ୍ୱାରା କି ଅଧିକ ଉଦ୍ଭାବନ ତଥ୍ୟ ବାହାର କରିପାରିବେ। ଏବଂ ଏ ଦିଗରେ ଆମର ସାର୍ ମାନେ ଯୋଉ ଅଛନ୍ତି ଡିପାର୍ଟମେଣ୍ଟ, ସମସ୍ତ ସାର୍ ମାନଙ୍କୁ ଅନୁରୋଧ କରିବି ସେମାନେ ଛାତ୍ରଛାତ୍ରୀ ମାନଙ୍କୁ ଗାଇଡ କରିବେ। କଳାହାଣ୍ଡି ୟୁନିଭର୍ସିଟିର ଅଧିକ ରିସର୍ଚ୍ଚ ୱାର୍କରେ ଅଧିକ ସଂଖ୍ୟାରେ ଛାତ୍ରଛାତ୍ରୀ ମାନେ ଯୋଗ ଦେବେ ଏବଂ କଳାହାଣ୍ଡି ୟୁନିଭର୍ସିଟି ଦେଶ ବିଦେଶ ନାଁ ରହିବ। ତେଣୁ ଏତିକି କରି ମୋର ବକ୍ତବ୍ୟ ସାଙ୍ଗ କରୁଛି। ସମସ୍ତଙ୍କୁ ଧନ୍ୟବାଦ, ନମସ୍କାର।
Today's world and in day-to-day basis. Thank you so much, sir, for the warm welcome address. Now, without much delay, and the purpose for which we all are together here. So let's start. And once again, I welcome to our today's esteemed speaker, Professor Bedangadas Mohanty, sir, Dean at NISER, Bhubaneswar, that is National Institute of Science, Education and Research. He is now working as professor in physics over there. So, he will be speaking on the topic new inventions in science. So it's going to be indeed interesting. And now I request sir to deliberate his topic to our students. Sir, please.
Thank you very much. Actually, thanks to Professor Sanjay Satpathy for inviting me to give this seminar. And before I start, just now, one of the colleagues from Kalahandi University told about creation and how this universe was created, or things like that he mentioned. So my research deals with understanding how the universe is created. Now, today I will not talk on that. But looking at the introduction, it motivated me to tell you that people from very beginning, mankind from very beginning has been wondering how this universe is created. Okay. So in science, there is one model called Big Bang. Today, I'm not going to talk on that, but I just want to flash to the young colleagues, young students. That's the model by which we know how universe is formed. But you know, in one of our scriptures, Rig Vedas, there is a hymn called Creation Hymn. And it's very nice English translation has been done by foreigners. And I'm going to read that out before I start my talk. So when was this universe created? And I'm doing this because this is very much closely related to the work that I do. So he says there was a time which is envisioned. There was neither non-existence nor existence then. There was neither realm of space nor the sky which is beyond. What was concealed? Where? In whose protection? There was no death then, nor deathlessness. Of day and night, there was no sign. Darkness was hidden in the darkness in the beginning. Then that which was hidden by void and formless, that one aroused by a great power of heat. But that out of which creation has arisen, who really knows? So how the universe is formed, you can see how beautifully the hymn is written in Rig Vedas, and people have thought about it. And at the end it says, how this creation has happened, who really knows? So that is not known. But let's come back to today's topic. I will focus on two discoveries in physics, specifically origin of mass and gravitational waves. These are contributions coming from two great scientists of the mankind, Newton and Einstein. And I will tell you interesting aspects of this. Okay. Now, all of you must have read this Newton's equation, right? F is equal to G m1 m2 by r square, where m1 is mass of one object, m2 is the mass of other object, separated by a distance r. Then the force of attraction is given as G m1 m2 by r square. All of you have learned in school books, colleges, and actually using these Newton's equations, people have put rockets in space. But do you know, there is some issue with this equation. This tells that the force is instantaneous. But as per Einstein, the other great scientist, no signal can travel from one to other with speed greater than speed of light. So force cannot be instantaneous. See, this equation which we have learned in school, colleges, tells us force is instantaneous. But Einstein's special relativity tells that you cannot have signal instantaneously transmitted. No signal can pass with speed greater than speed of light. So then how do we understand gravitation? So Einstein said it is you have to understand it in a different way. The space and time that you see all around is like a stretched rubber sheet. And if you put a massive object, what happens? The rubber sheet bends, right? Now, if you put another object onto this, it will roll down towards it. That is how gravitation works. It is not F, well, in some limit, it becomes F is equal to G m1 m2 by r square, but that is not the fundamental way by which gravitation works. Remember, it's because of gravitation, you know, Earth is rotating around Sun, Moon is rotating around Earth, we are walking. So, you know, it's at that fundamental level, he said, that's how gravitation works. Then he said that then how does the signal transfer? It transfers through gravitational wave. Okay. So people have been trying to detect this gravitational wave, but they have not been successful. How does this gravitational wave get formed? When space and time expands and shrinks. You can see the cartoon below. That is how gravitational waves are generated. Okay. Now, how will we detect this gravitational wave? See, gravitational wave carries the signal of gravity, and gravity is so important in our daily lives. Now, so then the idea came how to detect it. Now, you all must have, or at least those who have taken science, must have come across a Michelson interferometer. Okay. So what is that? I will tell you in a simple way. There is a source of light called here written as laser. And then there are two mirrors, M1 and M2. And then there is a screen. The light from the laser goes to this beam splitter, 45-degree angle. And then goes to, part of it goes down, part of it goes straight, reflects back from the two mirrors, and they interfere and form interference pattern in the screen. Why interference happened? Because there is a path difference created. Path difference led to phase difference, and you have interference seen. This experiment we do in our undergraduate lab. The photo on the top is an actual photo of a student performing this experiment in the lab, and you can see interference rings. It is this red bright and rings that you see. Okay. Now we can, now what is this interference? If you look at the things below, there are two waves at the bottom. If they come in phase, then they become bigger waves. Now look at the plot on the right corner. If they come out of phase, they cancel each other. Okay. So that is the principle of this interferometer. Now, imagine I set up this experiment. You know, path difference is most important thing. Now I set up this experiment where things are in phase. Okay. You have an interference pattern and a gravitational wave passed through. What will happen? It will change the path difference, so you may not have interference, the signal will go away. This is the technique which is used to detect gravitational wave. The only important thing is that how small a path difference. We don't feel, na? Do you feel any gravitational wave passing through it? You don't feel it because the signal is very, very small. How small is the path difference to be measured? I'll give you an idea. 1 meter is roughly 40 inches. A human hair, the one hair which you have, is 10,000 times smaller in thickness compared to 1 meter. The wavelength of light that you see is 100 times smaller in length compared to human hair. An atom has a diameter which is 10,000 times smaller in length than the wavelength of light. Atom has a nucleus. That nucleus is another 100,000 times smaller than diameter of an atom. And what we need to measure experimentally is changes in length of the order of 10 to the power minus 18 meter. 0.00018 zeros meter, 1 meter. That instrument has to be built. Then only we will be able to detect these gravitational waves. So 2 such big experiments were built. These experiments were separated. It was in United States of America, separated by 3,000 kilometer distance. Remember this Michelson interferometer, which we do in our experimental laboratory? This length L1 and L2 here, okay? To detect gravitational waves with this small length, the length of the distance of the beam splitter to the mirrors is 4 kilometers. Okay. So this fascinating experiment was set up and gravitational wave was discovered. What I am going to show you is the signal when converted to sound, and you will hear that in the next video. Now, how was this gravitational wave formed? Many billion years ago, 2 heavy objects, black holes, they collided, and that shook the space and time. And the gravitational waves has been propagating, and it reached Earth on 15th September 2000, I think 16 or 17, and hit this detector, and it was detected. So what I will show you now in a video is the sound, the signal converted into sound of gravitational wave, which was formed by collision of 2 massive objects in the universe 1.3 billion years ago. So just enjoy this. 1.3 billion years ago, 2 black holes collided and merged. This is a simulation how they collided and merged. They gradually came closer and closer to each other, rotating. They merged, and that shook the space-time, and gravitational wave traveled into the universe. You know, 2 black holes, they're coming and coming, rotating, coming closer and closer, and they will collide, and they will generate these gravitational waves. And it reached this experiment which I told you. You know what you are hearing? You are hearing a sound which was the signal corresponding to a signal which was created 1.3 billion years ago. See how fascinating this experiment was. And no wonder it had worldwide attention. Every newspaper covered it, says we now know how gravity works. And of course, the highest prize, the Nobel Prize in Physics, was given to these 3 scientists who made this experiment. Remember, they measured length differences of the order of 10 to the power minus 18 meter and detected these gravitational waves. 2017, they were given the Nobel Prize. So that's one fascinating thing which happened when you all were growing up, the students, you all were growing up. That time, this discovery happened. Now the next one. You all have read that, know about atom, right? Atom is a Greek word which means with something which cannot be further subdivided. But then Rutherford found that atom consists of a positively charged nucleus and electrons are revolving around them. Subsequently, it was found that the nucleus is made up of protons and neutrons. And subsequently, by 1970s, it was found that protons and neutrons are made up of still smaller object called quarks. Okay? So that is how we know what every one of us are made up of. Electrons, quarks, and gluons. Fundamental particles. People are trying to find out whether quark is further made up of something, but they have not yet succeeded. Okay. Now let me concentrate on this particle called electron. All of you know what is an electron. Flow of electron is current, right? It is such an important particle. Now, all of you have read that electron's mass is 9.1 into 10 to the power minus 31 kg. 0.000000031 zeros 91 kg. Now, how many of you worry about this small number? I'm sure not many of you worry about it. Okay, electron has 9.1 10 to the power minus 31 kg. So what? Right? You just read it in the book, and let's put it, if in the exam the question comes, let's put it. But have you thought what would happen if electron mass was not 9.1 into 10 to the power minus 31 kg? It is so small. If electron mass was 0, what would happen? Look at this equation. E is equal to, it's m0 c square, okay? M0 c square by root over 1 minus v square by c square. Now suppose I tell you E is not 0 and m0 is 0. How can this equation be satisfied? It can be satisfied only when v is equal to c. So that's what comes out from Einstein's relativity, that if a particle doesn't have mass, it will move with speed of light. What is an example? Photon. It is massless. It moves with speed of light. Now, if electron mass was not 0.000000031,091 kg, but would have been exactly 0, then electron would have moved with speed of light. If electron would have moved in speed of light, how will atoms be formed? If atoms cannot be formed, molecules cannot be formed. If molecules cannot be formed, compound cannot be formed. If compounds cannot be formed, cell cannot be formed. We won't exist. If electron did not have this mass, zero, if it had 0, we would not exist. Okay. Another consequence. Imagine electron had a mass which is 1,000 times smaller than what you read in textbook, or 1,000 times larger. What would happen? Now, all of you have read if you have taken science, that the radius of hydrogen atom, the Bohr radius, goes as some constants, and you see in the denominator lies the mass small m. This is mass of electron. If electron mass would be 1,000 times smaller or larger, then the atom size will be 1,000 times larger or smaller. Then the way the world that you see, our height are 5 feet, we would be either miniatures or will be giants. The world would look very different. Okay? Now the question is, who gave electron this mass? Or how did electron have this mass so that everything is peaceful in this world? Our heights are comfortable, building heights are comfortable, or we exist. So how did electron get its mass? So that question was addressed. In order to understand that, I will try to explain to you by taking example of wind. Now in physics, there is some concept called fields. Field doesn't mean cricket field or football field. It is physics, scientific field. Now I will not go into technical details, but I will try to explain to you what is a field by taking wind as an example. Now wind exists everywhere, right? I mean, you find air everywhere because we are able to breathe wherever we go. Somewhere you do not feel it. So somewhere it's like 0. Somewhere, suppose you are below a fan, you can feel it. So somewhere it is 0, somewhere it is not zero. What are the waves associated? Sound wave, right? Sound wave needs air or a medium like air to propagate. Okay? So what is a field? A field is something which exists everywhere. Somewhere it is zero, somewhere it is not zero, and the wave associated, it has a wave associated with it. Okay? So what's a field? Exists everywhere, somewhere zero, somewhere non-zero, and has a wave. But quantum mechanics tells every wave has a particle associated with it, or wave particle duality. Okay? So that's a field. Let's see if this example holds or not. Electromagnetic field is something which you all know. Electric field exists everywhere, right? Otherwise your mobiles won't work, right? Now somewhere it is zero, you don't feel it. Somewhere you feel it. And don't do this at home, but there are these power sockets. If one puts, one gets a shock, like the hairs will all rise, as in case of this small child, right? Now what is the wave associated with electromagnetic field? It is the light waves, and the particle of light is photon. Okay, so that's the definition of a field. So there was in early universe a field called Higgs field. It existed everywhere, and it is associated with a wave called Higgs wave, and its corresponding particle is Higgs particle, but it was never zero. Okay, why it was never zero? Because if it would be zero, electron would not get mass. Now how electron got mass? Now let me explain to you by taking one example. This is an example to explain how electron-like particle got mass using this cartoon. This won the best explanation prize in UK. So let me tell you how electron gets its mass. You see, there is a room full of political activists. Okay. Now an important personality like Prime Minister walks into the room. What would happen? People will meet him, right? Greet him, tell him about their problems, issues, share with them their views. So Prime Minister gets surrounded by a bunch of people. People want to meet him, right? So here was the electron, and people wanted to interact with it. So electron, you see how the particle got mass? Particle gets mass by interaction. Okay? So there was electron, there was Higgs field, and when electron passed through the Higgs field by interaction, more it interacted, more will be its mass. Electron interacted less, so it got accordingly its appropriate mass. Okay? So remember this concept. Mass is generated by interaction. Now, how can we experimentally prove this concept? So, people said, if you can discover the Higgs particle, remember every field has a wave and a particle. If you discover this particle, this idea was given by Peter Higgs, so it is called as Higgs particle. If you discover this particle, then you know the field existed, and electron interacted with the field to this much amount. That's why it got this mass. Okay. So people started building machines to discover this particle. Which particle? The Higgs particle. Now I will tell you what this machine is. This machine is called as the Large Hadron Collider, LHC. It is the largest or the biggest accelerator in the world. It is located in Switzerland. The circumference of this accelerator is 27 kilometers. Now the accelerator needs about 9,000 magnets. They have to be kept at a temperature minus 271.3 degrees Celsius. Remember, 0 degrees Celsius is ice. This is 271 degrees Celsius below. Normal pressure is 1 atmosphere. The machine has to be kept, the beam lines has to be kept at 10 to the power minus 13 atmosphere, 10 times less pressure than at moon. Here, the particles are collided in such a way, it's so high speed. It takes a proton, a particle proton, which is present inside the nucleus of an atom. In 1 second, a proton moves 11,245 times this 27-kilometer ring. That is the speed with which the proton moves, and then it is collided. Okay? So that's the machine which was needed. This machine generated temperatures which is million times larger than the temperature of sun. And it mimicked the universe, which was when the universe was 1 microsecond old. 1 microsecond means 10 to the power minus 6 second old universe. So let me give you the temperature which was generated in this machine. Now the lowest temperature recorded in the laboratory is 10 to the power minus 10 Kelvin. If you come to NISER or institutes like this, then people work with trapped ions whose temperature is 10 to the power minus 6 Kelvin. The universe temperature is at average temperature of this universe is roughly 2.7 degree Kelvin. The room in which you are sitting, the temperature in Kelvin is 300 Kelvin. The temperature in the solar surface is 6,000 Kelvin. In the interior of sun, the temperature is million Kelvin. If you do a thermonuclear explosion, the temperature will be 10 to the power 9 Kelvin. And by collision of two particles, protons, the temperature which this machine generated was 10 to the power 12 Kelvin. Temperature which existed in the early universe. In a microsecond old universe was created momentarily in this facility. So now I will show you a video showing you how this Higgs particle was discovered. So this is a video. It's zooming on into CERN, which is in Switzerland. You can see the Geneva airport here. This is the Large Hadron Collider. And we will first go to make proton. Proton is ionized hydrogen. The protons are, hydrogen is stripped of its electron and the proton is accelerated. Acceleration of the proton happens in stages. First proton synchrotron booster. Then it is fed to proton synchrotron. So proton goes, circles in a faster speed. It has to go 11,245, remember 27 kilometer. So it goes to the next stage of acceleration, super proton synchrotron. And then it is fed to this 27 kilometer ring, the Large Hadron Collider. Two protons going in counterclockwise direction. The protons come and collide. In the center of our detectors, particle comes out. And using these particles, we discovered the Higgs particle. Okay? So there were 4 experiments. One you see here is called Atlas. Protons collided, particles came out. The data from the detectors is transferred electronically, digitized, stored in data centers. And you need so much computing in order to analyze the data that computers all over the world was linked together like a grid, like an electric grid, in order to process this data. Okay? You will see how computers all over the world were connected in a moment. You see, all these places that you see here, the green lines are the connections of using all the computing power to analyze the data. And then you try to reconstruct the event which happened. Okay. Now you will see a histogram, and in the histogram you will see a small peak. This small peak that you see is the signal that we have discovered a new particle. Okay, and that is called Higgs particle. It is called Higgs boson. And why this boson is named after our own Indian scientist S.N. Bose, who told that these are class of particles which have integral spin. Okay, with this discovery of Higgs boson, we knew that Higgs field existed. Now that Higgs field existed, electron interacted with the Higgs field and got its mass. That is how we know how electron got its mass. That is how we know why we exist. Because if electron would not have got mass, we would not have existed. And certainly that brought worldwide media attention. And you can see all papers across all countries celebrated that we now know how electron got its mass. We now know origin of mass, and we now know why we exist, because electron had non-zero mass but small mass. And Nobel Prize was given to Peter Higgs and Francois Englert for their proposal how this electron gets mass, and the experiments which discovered this Higgs particle. Okay. So let me summarize these two exciting things. We are very lucky to have existed in a time when the two distinct discoveries were made. One is why electron has 9.1 10 to the power minus 31 kg mass. And you know, still people do not know what is the origin of electron charge, 1.6 10 to the power minus 19 coulomb. Who gave it? How did it get it? We do not know yet. And the other was, we discovered gravitational waves. Remember, 1.3 billion years ago, the signal traveled and reached us in 2015-16. And you heard the sound of that signal converted to sound. We now know how gravity works. Okay? There are still many more discoveries to be made. For example, the universe is continuously expanding. Where will it go? Will it go and blow itself off? Or it will capsize into a dot? So will it be a big rip or a big crunch? We do not know. Now you will be surprised to know that all that you see in this universe is only 5% of the matter, energy matter budget. Rest 95% we do not know. So you see, there are many, for young people, there are many discoveries yet to be made. And I have only told you where is the universe going, what is dark energy, what is dark matter. Remember, all that you see in this universe is only 5%. Rest 95% is supposed to be dark matter and dark energy. It's named dark because we do not know what it is. I will end on a little bit philosophical note. You know, how big is our universe? You know, this is river Rushikulya. It is called Ganga of Ganjam. Its length is 165 kilometers. We have our longest river in Odisha, Mohanty, which is 494 kilometers long. Total, of course, from the origin where it flows, it is 8,857 kilometers. Then comes the longest river in our country, which is Ganga, 2,525 kilometers. Then comes, remember, 2,500 kilometers is the river which flows in our country. Now, what is the diameter of Earth? It is 12,742 kilometers. Now, what is the diameter of the solar system? Now, kilometer is not enough. We have to talk of astronomical units. We say it is 122 astronomical units. Okay? That is 150 million kilometers. Now let's see. Now, our solar system is just one in our galaxy. You remember our galaxy is called Milky Way. A similar galaxy is Andromeda galaxy. Do you know what is the diameter of that galaxy? It is now million kilometer or astronomical unit doesn't hold. We have to go light years. Distance traveled by light in 1 year. Light speed is 3 into 10 to the power 8 meter per second. With that speed, whatever distance light travels is called in 1 year is light year. So the diameter of a galaxy, typical galaxy, is 220,000 light years. And it has 10 to the power 12 stars like our sun. Okay. Now that's one galaxy. Do you know there are clusters of galaxy? Okay. Now these clusters of galaxy are 2 billion light years away. And each cluster has, like Milky Way, 10,000 galaxy. Remember, each galaxy had 10 to the power 12 stars like sun. Okay. Now this cluster of galaxy forms the visible universe. If you try to measure the visible universe diameter, it is 10 to the power 26 meter. Okay. This is our universe. Okay. Remember, we started with, this is just a summary of what is the size of this universe. Okay. And do you know where we are? We are in this universe in one galaxy called Milky Way. We are also not in the center of the galaxy. We are at one corner of the galaxy. Our Milky Way galaxy, at one corner we are. Because center of the galaxy is usually having a black hole. Okay? And yet we spend all our day thinking about many aspects which are irrelevant, fighting with each other, not trying to do good for everyone, forgetting that we are just a speck of dust in this vast universe. That's why I wanted to show you how big is this universe, because science makes people humble. You can see from the vastness how miniature we are. Okay? I will end with this philosophical remark. Science provides the most humbling experience. Look at your position in the universe. Universe is 10 to the power 26 meter diameter. We have millions and millions of galaxies. In a galaxy, we have 10 to the power 12 stars like sun. And we are just one star. Even in that is itself 150 million kilometers. And we are in Earth. And inside Earth, we are in one particular place. Okay? So know your position in the universe. That will make you humble. Second thing that I want to say is a quote from Swami Vivekananda. Pleasure is not the goal of man, but knowledge. Pleasure and happiness comes to an end. It is a mistake to suppose that pleasure is the goal. The cause of all miseries we have in the world is that men foolishly think pleasure to be the ideal to strive for. After a time, man finds that it is not happiness, but knowledge towards which he is going, and that both pleasure and pain are good teachers. Okay? Remember, let's gain knowledge and dream big. That would be my advice to my younger colleagues and students. And I will end finally with the Nobel laureate in science from India, Professor Sir C.V. Raman. He told this when he went to explain what is Raman effect. When he discovered Raman effect, for which he got Nobel Prize, he went to colleges in Tamil Nadu and he tried to give this message. And here is a quote from what he told that time. Quote is meant for students. Okay? Remember, youth is the most glorious time of all. I have said elsewhere that most of the great discoveries in science have been made by young people. It is not the experience or wisdom that the old age brings, but the freshness of outlook, the indomitable desire to achieve, Which is the characteristics of youth that makes discoveries possible? It is this that makes life worthwhile. If only you realize this and realize that here I am still young, let me see what I can do, that all discoveries will become possible. Thank you very much for inviting me. I hope the student, both last two things which I told, you will remember and carry on when you discover new things in this world. Thank you.
So much, sir. Thank you so much. I request for a huge round of applause from our students. I think it was a very, very engaging session for today's, from the point of view of the students, because I saw that all the students were engaged thoroughly and they were completely enjoying for today's talk by Sir. So I would say that Sir has clearly, in a very simple way, in a very elaborate manner, explained about the origin of mass as well as the concept of gravity and how you understand gravity. Sir, I personally got very much clarified on this topic, though I am not from a core physics background, but as a science student. So it was very simple and it was very much enjoyable and it was very much useful from the student point of view as well. So thank you so much, sir, for accepting our request and delivering this topic, which is, I think, a mysterious thing in the physics got clarified today. So thanks once again, sir, from the core of our heart on behalf of Kalahandi University. Now, I request our students, if you have any queries, you can ask and we can discuss with sir. So anyone from the student side and anyone who has joined us online, if you have any queries, you may ask.
Yes, somebody says why it is called boson. There are two classes of particles. One is called fermions, who have spin is half or like that, to 1 by 2 or 2 by 3, like that. And there are class of particles which have integral spin or zero. Those are called bosons. Now, fermions is after Enrico Fermi, who gave the Fermi-Dirac statistics, which these particles follow. And bosons are due to S.N. Bose, our own scientist, who gave Bose-Einstein statistics, which these particles follow.
Now, Vice Chancellor Professor Sanjeev Kumar Sarpati sir, who is the person behind this talk, who is the person for arranging this webinar to speak few words on today's occasion. So please.
Thank you, Vedant, for the nice talk. We'll preserve it. And what I feel about my students, it has not gone over it, rather has pierced into their heads and bring in the soul of knowledge. And definitely not desire that even a minute thing will be affected. Rather, I was looking, many of you have taken note of it. You can again go through this talk and listen it as many times as you can. Two things only I will underline about what is told by Vedanta. First is, understand that you are very small in this great universe. If you think yourself as big, then there will be pride. There will be many things which will come in it. But once you will feel that I am very small, very minor particle this great universe, then you will be humble. And that is what which is required. When I talk of that, I can also put the Namranti Parinamrukhya Namranti Vinodha Namranti Sajal Dwara. The tree with fruits is polite. The cloud having the power of raindrops is polite. So similarly, the more you will be polite, the more calmness will be there in your brain, and you may get new ideas to go ahead. So the next thing which are there, I just underline it. It is a clarion call to all the young people who are listening here that there are many things which are yet to be invented. So you can be on the line as you are in the subject. Be calm, be thoughtful, have an indomitable will, because all of you have ignited minds. Don't make it sleep, and just the time will go away. I was again remembering Vedanta in an Olympics. PT Usha lost the bronze medal for 100th of a second. And here again, you make that time much lesser. 31 zeros, then 9-1. What a small, minute thing, but that can make a difference. All those who feel themselves are weak, they have the pride, they don't make a big difference. Even a small rat can conquer the elephant or going to the other side of the mountain faster than the elephant. So thank you, Vedant, for igniting his minds. I'll be happy if they will not sleep tonight and think of what you want to talk about, how we can, how it has used to their minds, and then go ahead. Thank you, Vedant. Thank you. Thank you, Dean.
Thank you very much for inviting me.
Thank you so much, sir, for always encouraging us, for always igniting our young minds. Thank you once again. And I would again like to quote that if we, as sir said, if we understand that how tiny we are in this big universe, then definitely we will be very humble and we will do something. And humbleness definitely increases the creativity and something to do in our life. So with this, I request our assistant professor in physics, Nakul Kumar Maji sir, to give a formal vote of thanks on today's occasion. So.
Namaskar. So first of all, I will start from our dean, Kalahandi University, head of the institution, Professor Sanjay Kumar Sarpati sir, and Register sir, Pitambar Bhai sir, then CYF sir, Suresh Pedisika sir, CPJC, Jaydev sir, and all the HODs who have joined physically as well as in the online mode. I am very thankful to them, and especially to my all the students, all the department students who have joined here and listened carefully, and they have understood. I hope they have all understood it, because I have clearly mentioned all the pictures and all the we can take, that is, we are saying, in a simple manner. And I will say that this is only possible because of our team and our subject matter officer, who is putting all the efforts, that is continuous efforts, is put by all the team members and as well as our technical teams that are supporting us. so that we are clear. And finally, I will thank our advisor, that is Bedangadas sir. Sir, I will say you are inspiration to all the PG students as well as all the students who are pursuing in all the abroad, like those who are interested in higher physics, as well as physics, we are one of the inspiration to us. And this is we you got award for something, so got award from Odisha, and you are the first person who has got it. And the second person was is who has got in the that is Ramakrishnan sir. And I hope one day you will bring Nobel Prize to us. That is for the India. So I hope my students will go with your life and they will see and they will try to discover in future. Thank you, sir. Thank you all. And thank you, Kusum ma'am, for organizing this good evening of events. And our Sradha, PG second year students, she has given her effort in giving his own ideas of our guest. Thank you, sir. Thank you. And okay, so and I thank Lipsa Marana who has our constant support for having the singing part that is welcome song to our institution. Thank you.
Thank you so much, Rahul sir. Once again, I thank you all for attending today's session, for participating in today's session. And lastly, I thank all who are directly or indirectly helped us, and special thanks to our technical team who have made really nice arrangement to make it audible and reachable to all of you. So thanks, and a big round of applause for all the team and all the support. Once again, now I will request Lipsa to do the Santi part and have a closing remark. Om Sarve Santu Niramaya Sarve Bhadrani Pashyantu Ma Kaschit Dukhabhat Bhavet. Om Shanti Shanti Shanti. Thank you and have a nice time.